Hey pre-calcers, I wanted to take a look at some of the select problems from your practice test. That's going to deal with 4.4, inverse trig, and graphs of sine and cosine. This first problem has you given this point of -7, 24 on the terminal side of an angle theta. Find the exact value for each of the 6 trig functions of theta. So we know that we're given this point here, like an xy point. So the first thing I would do in this case is draw out what this would look like. So it doesn't have to be too crazy. You can draw a simple xy plane. You know that -7, 24 would be out here, which would be -7 in the x direction, and then up 24 in the y direction. Since our angle theta is on the terminal side, that means that angle theta is going to be in here. And we can map out a few things here. So what I would personally map out is that this side here we can refer to as -7, which in this case I would just jump ahead and say that this is going to be our adjacent side. Because recall, if we're dealing with trig, we have our opposite, we have our adjacent, and our hypotenuse. And I would refer to this positive 24 as our opposite. So what do you think we're missing in this case? What else do we need if we're going to get all 6 trig functions here? Well, we know we have our 2 bases for the triangle, and we're missing our hypotenuse. So if we do Pythagorean theorem, so let's square 7. 7 times 7 is 49. If we add on 24 squared, that gets us 625. And if we take the square root of 625, that's 25. Okay. So we know based off of Pythagorean theorem, this is going to be positive 25 for our hypotenuse. And again, if you're not convinced, you can always fall back on square root of -7 squared plus that 24 squared. Taking the square root of that's square root of 625. Cool. Let's take this further. If we're going for sine, we know that that's going to be the so our opposite is 24. And our hypotenuse is 25, so sine's pretty simple there. Cosine is adjacent over our hypotenuse, so -7, recall that was our adjacent, over our hypotenuse, which is 25. Key thing here is that you have to keep any negative signs that come up. Tan ain't too bad, that's opposite, which is 24. Over our adjacent, which is -7. And recall that this does not use the hypotenuse, so that's okay. You should have seen cosecant, secant, and cotangent before. Again, those just flip around the 3 trig functions we've already seen. So cosecant is going to be 1 over that sine of theta. So just flip that fraction to 25 over 24. Flip the cosine fraction to get secant, which is going to be -25 over 7. And for tangent, flip that -24 over 7. Now it's a -7 over 24. Simple. Good rule of thumb for these problems is to sketch them out for sure and just try to map them out and recall your trig functions. Use your notes if you get stuck. This is something you should have seen in 4.4. So if you were stuck on anything there, I would look back. The next 2 problems are similar. I'll sketch this one out real quickly. This is saying that sine of theta is in quadrant 2 and has this fraction. So I believe at some point in the videos I mentioned that this would be quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. Some of you said this in the mastery checks, which was cool to see that you got a hold of that. So this triangle would be in quadrant 2. So definitely in here. We know that our opposite is going to be 15. Our hypotenuse is 17. You would then want to get a hold of this angle here. So use Pythagorean theorem for that. 17 squared should be equal to 15 squared plus your missing side being squared. And then solve for that. And then you would get all those trig functions the same way. Just be careful because you no longer need to get sine because you already had that. Let's see what else we got here. Same kind of thing. This is just a little bit more cryptic, saying that the theta is between 270 and 360. So that would imply that your angle is going to be in this kind of triangle seen here. And then you would take that further and say this is 15, this is 17, get a hold of this, do all those trig functions, and keep that one going. And recall that since your height here is negative, you would want to keep that in mind, that you're going to have a negative 8 here for your height. Cool. Reference angle, these ones aren't too bad. I definitely have this practice seen throughout, so recall that 169 degrees kind of takes you out to here for referencing the unit circle. So that's 169. So this leftover increment here to get us to 180 would have to be just 11 degrees. Pretty simple. Notice that for your answer, you only need to write the number. You don't have to write degrees in. So just write the number you need for these. For the reference angle here, 277 would be past 90, past 180, past 270. We have 7 degrees in here, but we really want to highlight on the 83 that's here. So that's why 83 is the better look here. Because recall, we're always trying to get our angle based around this positive x-axis. Let's keep that in mind. If we're using a reference angle to find tangent of 240, this is definitely going to be using your knowledge of special right triangles. So 240 would be approximately here with a 30 degree difference here and a 60 degree difference here. Recall that for 30, 60, 90, your smallest side is here and it's going to be negative. Your smallest side times root 3 is going to be here. And recall that your hypotenuse is just 1. So let me clean this up a bit. So your hypotenuse in this case is just 1. Let's see what else. Recall that this is going to be the smallest side times 2. So that means that this is going to be negative 1/2 for your x-coordinate. And then this would have to be negative square root of 3 over 2 for the y-coordinate. If you're taking tangent of this, recall that this is the opposite over the adjacent. So you would be taking this negative square root of 3 over 2, divide that with negative 1/2, rewrite this with reciprocals, so just like this, multiplying with that negative 2 over 1. So recall that this is the reciprocal for this negative 1/2. Your 2's can then cancel. This then leaves you with a negative times a negative. So the final outcome is just positive square root of 3 over 1. And you'll just want to write square root of 3. So note that if you were going to try and use your calculator for this, chances are it's not going to kick you back square root of 3. So actually sketching this problem out is going to be pivotal for you. So don't just rely on your calculator. It even says here that you can use radicals as needed, use integers or fractions, but not a crazy decimal. Inverse trig is up next. We have an angle of 37 here. This is a right triangle, so inverse trig is fair game. We're trying to solve for this length here. So let's think. What trig function is going to use our adjacent? Like imagine you're standing here. You definitely have your opposite, and you have your adjacent. So which trig function uses both of those? Well, recall that tangent of theta is our opposite over our hypotenuse. So if our angle in this case is 37, tangent of 37 degrees should be equal to x over our 30. Or sorry, not hypotenuse. Yeah, that would have been bad. All right. Toa, adjacent. Cool. All right, so how can we go about solving for x here? What do you think? Should be saying we can multiply both sides by 30. 30s can cancel. If you let your calculator do the work here, keep in mind that your calculator should be in degrees, not radians. You should get approximately 22.61. Recall that for this, you're rounding to the nearest hundredth. Let's see what else we got. More inverse trig. This is solving for... Wait, what? Yeah, you didn't even have to do inverse trig here. This was just solving for missing side. All right, so that's right. We'll do one with solving for our missing angle. This will work. So notice that we're solving for an angle here. So anytime we're trying to solve for an angle, this should imply, and this should be something we recall, that we need to use inverse trig. You saw the one video where it starts with what you would do for a Klondike bar. In this case, you should be asking yourself, what would you do if you don't have any angles? And that's the case here. So when that happens, we're dealing with inverse trig. So let's think this out. We have our angle. We have a side that's opposite. And we have our hypotenuse. So what trig function uses the opposite and the hypotenuse? Think of SOHCAHTOA. Which one uses the opposite and the hypotenuse? You should be saying sine. So we can say that sine of x, and we'll take the inverse. No, let's not do that yet. Sine of x is going to equal 5 over 21. So that implies that if we were to take sine inverse of 5 over 21, that equals x. So do that. Use your calculator. And recall you're rounding to the nearest degree. So your calculator would take care of the work here. Dealing with graphs now with sine. Recall that the term in front is our amplitude, and we always take the absolute value of our amplitude. So the absolute value of -8 is just going to be +8. So that's our amplitude. If we were going to graph this out, this would imply that we're going to do a normal period cycle, but in between 0 and pi, it should go up to 8. And then between pi and, pi and, oh no, sorry, that's right, 2 pi. So halfway in between there, this should go down to -8. Because recall, this is sine. Simple. You had that worksheet on this too, so that should help. Yeah. Oh, whoa. Sorry, negative. So that means that instead of going like that, our points are reversed. So let's switch that up. So instead of having the 8 up here,